Hello viewers. In the third video, we have discussed the concept of centripetal force and the centrifugal force for the circular motion. So in this video, we are moving towards the next topic, that is the maximum safety speed of the vehicle which is moving along the curved road. So imagine the vehicle which is moving along the curved road. Basically, it is performing a circular motion because this curved road is act like the arc of the circle, and the required centripetal force here is provided by the frictional force of the tires and between the road surface. The frictional force is given by mu mg, where mu is the coefficient of friction between the tires and the road surface, m is the mass of the vehicle, and g is the acceleration due to gravity. So here the centripetal force is provided by the frictional force, that is m v square upon r is equals to mu mg. The formula for the centripetal force in the third video we have in the previous video we have discussed the formula for the centripetal force, that is m v square upon r. So this m and this m get cancelled, so the remaining term is v square is equals to mu r g, and the final term is v is equals to under root mu r g. So this is not a v, this is a v max actually, and this is the required maximum safety speed of the vehicle along the curved road. Now, what is the banking of the road? There arise the two cases for avoiding the accident circumstances. If the road surface is rough, it occurs the wear and tear of the tires of the vehicles. If the second case is if the road surface is very wet, then there are the much chances to of the vehicle that it may be get thrown off or it may be get slipped. To avoid these two factors and also to avoid the accident, the banking of the road, this concept is derived. So what is the banking of the road? The banking of the road means the raising of the outer edge of the road over the inner edge at a certain angle is called as the banking of the road. So imagine the vehicle is moving along the bank curved road, and this road is banked at a certain angle theta from the horizontal. Suppose this is the vehicle, these are the tires of the vehicles. Now we have to observe the forces which the vehicle is exerting on the road and the forces which the road is exerting on the vehicle. So the first force which the vehicle is exerting, that this is its own weight, that is mg, which is perpendicular to the road surface. At the same time, the road is exerting the normal reaction to the vehicle, and which is perpendicular to the body of the vehicle, that is n. But this n is neither vertical nor horizontal, so we are going to resolve it into two components, that is the vertical component and the horizontal component. But this normal reaction is making an angle theta with the vertical, so we are going to write here n cos theta and here n sin theta. Now the remaining is the frictional force which is between the tires and the road surface, and it lies as like this F. It is also neither vertical nor horizontal, so again we are going to resolve it into the horizontal component and the vertical component, that is F, and this is also, but here the F is making an angle with the horizontal component, so here we are going to write F cos theta, and here we are going to write F sin theta. So this whole diagram is summarized as, suppose this is the center, from this is the weight of the vehicle mg, this is the normal reaction exerted by the road on the vehicle, this is the vertical component of the normal reaction, and this is the horizontal component of the normal reaction, that is n cos theta n sin theta. This is the frictional force which lies in the third quadrant. So again it is resolved into two components, that is the horizontal component is F cos theta and the vertical component is F sin theta. So this diagram is important for resolving the forces and carry out the required safety speed of the vehicle on the bank curve road. So I am going to rough this imaginary diagram. So first balance the vertical forces in the diagram. The first vertical force which is in the upward direction is only n cos theta. The second vertical forces which are in the opposite direction of n cos theta and in the downward direction, that is f sin theta and mg. That is f sin theta plus mg. I have written here plus because the both forces are in the same direction. Now write in terms of mg at LHS, that is mg is equals to n cos theta minus f sin theta. Give it as equation number 1. Now balance the horizontal forces in the diagram. The horizontal forces in the diagram are n sin theta plus f cos theta. I have again written here plus because the both forces are in the same direction. And these two forces provide the necessary centripetal force to the vehicle for moving along the curved road. That is mv square upon r. So write in this form, that is mv square upon r is equals to n sin theta plus f cos theta. Give it as equation number 2. To find out the maximum safety speed, divide equation 2 by equation 1. So we get mv square upon r divided by mg is equals to n sin theta plus f cos theta upon n cos theta minus f sin theta. Now this m and this m get cancelled, so remaining term is v square upon rg is equals to, take out the n cos theta as a common term, therefore 1 upon n cos theta in the bracket n sin theta plus f cos theta upon 1 minus f sin theta upon n cos theta. So divide by n cos theta to the whole numerator, that is this term as it is v square upon rg. N get cancelled, sin theta upon cos theta is tan theta plus f upon n cos theta get cancelled, that is f upon n. Denominator as it is f upon n and sin theta upon cos theta is tan theta, that is f upon n tan theta. Now the another formula for the frictional force is F is equals to mu into N. That is mu is equals to F upon N. So we can replace here F upon N by mu, since F is equals to mu into N. So V square upon Rg is equals to tan theta plus mu upon 1 minus mu tan theta. Now write in terms of V. So here there is a square of V, so I am going to write in the square root V is equals to under root Rg in the bracket mu plus tan theta upon 1 minus mu tan theta. So this is the required or important equation for all terms, all types of condition when there is a theta given, and when there is a mu, that is the coefficient of friction, is given. So from this you can calculate the maximum safety speed of the vehicle on the bank or road, whether it is bank or not, whether there is a frictional force or not. So from this equation there arises the two cases, that is when the road is horizontal, it is not bank, then theta equal to 0 and tan 0 is equals to 0. Therefore V is equals to mu Rg. Now the second case is when the frictional force is 0, that is when in the rainy season the road surface is wet, the frictional force is negligible, that is mu equal to 0, then V is equals to under root Rg in the bracket 0 plus tan theta, that is V is equals to under root Rg tan theta. In this equation, the mu is not given because the frictional force is negligible and it is neglected. But in this equation, in replacement of the frictional force, the road is bang. So here the value for theta is will be given for calculating the maximum safety speed. If you want to calculate the angle of banking, that is theta, then you can write tan theta is equals to v square upon rg. So theta is equals to tan inverse of v square upon rg. So these are the four. This is the most important equation. From this equation, there arises the two cases, and the two cases gives v, and these two cases gives the two formula for solving the numericals. So I think this is a sufficient video for you to remember the concept or to understand the concept of maximum safety speed of vehicle on the bank of road, and to understand the concept of what is the banking of road. Also, you can calculate the angle of banking by this formula. And according to the board examination view, this derivation is not as much as important, but the formulas are very important to calculate the problems based on this concept in the board examination as well as in the CET examination. So watch it thoroughly and just remember this concept. And thanks for watching.